Yeah, hello. Shall we start the session, sir?
Yes, sir. Please go ahead.
Yeah. Yeah, hello. Good evening to all. Now we are going to start the session with data structures in C programming. So as part of the data structures, instead of in the next later sessions, we will give you the introduction and all. Now I'm directly moving to one of the topic called searching techniques. Searching techniques in C programming. Okay, so what are the different searching techniques we have? Like linear search, binary search, Fibonacci search. So what exactly the purpose of the search? So for example, if you are given a list of records, each record has an associated key. Given efficient algorithm for searching for a record containing a particular key. Efficiency, how can you identify? Efficiency is quantified in terms of average time analysis. That means number of comparisons to retrieve or to identify a particular item. If you observe in this diagram, that means whenever you want to find some data, say for example, you want to search, you want to get your result. How you are getting your result? Simply you are searching your role ID, right? Your ID. So once if you are searching your ID, it is displaying all your marks memos, like your ID, your name, your college, and what are the marks you have retrieved, right? What are the marks you got? So while you are getting some particular data about the particular information of the student or employee or the product or whatever it may be, you are going to search based on the particular key value. As part of the student identification is the key. Student ID is the key. Your roll number is the key here. Likewise, for every employee, they may have employee ID. So with that key, you are searching. If the data is available, you are retrieving. You are searching with your, the products either in Amazon or Flipkart somewhere. You are giving some kind of name. You are searching with the name, some product name. Okay, either MacBook or some kind of things you're searching, your mobile you're searching. So if the product is available, then it is going to display the data and it is going to be displayed, and it will be either in the web or whatever it may be, the relevant products are going to be displayed fine. Okay, but what we are doing here, we are going to search. I'll give you different IDs, either numbers. Okay, all the student IDs or any numbers. I'll give you the list of IDs as an array of integers. We can give the input of the list of numbers. And what is the another list? What is another list? The item to be searched as an input. I'll give you. Say for example, in this, I have given this number. Then if this number is available, the relevant name is displaying, person is displaying, that image is displaying, whatever it may be, we can do. That is the application. Okay, so here we have two types of searching. One is linear search and the one is binary search. Now, how we are going to do in the linear search? I'll explain the linear search mechanism. After that, we will go ahead with the disadvantages of linear search and how to solve those problems, like how to improve the time complexity with help of the bubbles, with help of the binary search. I'll explain you all. Now I'm going to open Paint to explain about the linear search techniques. So in this linear search also call it as sequential search. Linear search is also called as sequential search. Okay, sequential search, nothing but you need to search all the values one after the other. Say, for example, you have the data like number 2, 1, 7, 12, or you can take 4, number 4, number 6, number 9, like this. You can take 78. So that means, is the values are in arranging in the any order, specific order? No, right? The data is not arranged in any order. Okay, this we call it as any zigzag manner you can mention. Now, what kind of searching algorithm we are using? Linear search. I'm talking about linear search. Fine. So in this linear search, what we are going to use? This is the linear search I'm using. So what is the input here? We have an array is an input. Array A is an input. How many elements you have? In this array, we have 1, 2, 3, 4, 5, 6, 7, 8 elements we have. Okay, we have 8 elements. You can take maximum size 8. Okay, these are the elements. So you know how to create an array A with the size of 8 and all the elements you can read. This is one input you can give. Array nothing but it is a similar type of elements we have to store into the an array, right? As you know how to create an array and how to store the data into the array, right? Fine. Now you need to search one particular item, right? So that data I'm going to store into any variable. So for example, in this case, I will take another variable. Variable name is item. Now tell me which element you want to search. Say for example, I want to search the item number 9. Okay, the value 9 I want to search. Now I want to search with starting onwards, right? So what is my variable? So now I'm trying to tell you the logic. So my dear students, you should understand the logic. Based on the logic, you should develop the program, right? Don't by heart the program. Okay, you should understand the logic. Based on the logic, I will try to implement the program. Okay, fine. Now you tell me, now you have an item. Okay, what is the variable? Item. That is, you are going to be search an element, right? What is the element number value? 9. So is this item equal to, how you are going to search this? Okay, this is A of 0, right? A of 0. Okay, fine. So if item equal to A of 0, is that item equal to A of 0? No, right? False. Then you move your pointer to the next. Your item is moving to here. Is your item is equal to A of 1? This you know, right? A of 1. Your item value is 9. Is 9 equal to 1? No, you are moving. So how we are going to do like this? As you know, we have for loop, right? As you know, you have for loop to navigate, moving from one location to another location in this array elements, right? For I value, okay, you know this, I value equal to 0 to less than or equal to 8. That you know that you can do. Okay, I don't want to write all the things here. You can write the for loop. Now, so what is the, how you are going to identify moving from one location to another location? For I equal to 0. That means A of I. So I'll write that one also parallelly. So parallelly, I will tell you the logic also. So you should understand the logic. You should frame the logic by understanding the concept, right? So now I need to search with item equal to A of 0. Next A of 1. If item equal to A of 2, A of 3. Likewise, I will search each and everything. If it is true, then I can say element is found. I can come out of that, right? If the item is found in between, can you move to the next element to search? Not required, right? You don't need to move. Then you should stop your for loop, right? So how many times I have to search? You have 0, you have 1, you have 2, you have 3. How many times you have to search? So that's why you need to mention a for loop, right? For I equal to 0, what is the logic? For I equal to 0, I less than or equal to, how many elements we have? 0, 1, 2, 3, 4, 5, 6, 7, right? 7 means 8. So 0 to 7. Okay, less than or equal to 7, 0 to 7. Then I plus plus. Okay, this is the logic. And then, yeah, for every time what you are going to search, for every time what you want to search, if your item to be searched, that element is equal to A of I. A of I nothing but what? Every time your I value is 0, 1, 2, 3, 4, 5, 6, like this. So the item value, whatever the element you are going to be searched, is equivalent to A of 0 first time? No. Then what happened automatically? I value incremented. Then is your item is equal to A of 1? Value is 1 here. No. Then incremented by 1. Yes, if it is true, what I can say? Yes, sometimes your searching element is 12. Immediately your 12 is identified. So do you want to move and all that elements? No, right? You want to come out. Yeah. Then what I can say? If this item is available, okay, within the for loop, right? Within the for loop, I'm going to check with my if conditions. So what is my if condition? Simply if item is available, I can say item is available, right? Item is found. Which location? Wherever your I value is there, right? I value is there. But what do you want? You want to say your item a 9, where it is available. Do you want to count like 0, 1, 2, 3 or 1, 2, 3, 4? So for understanding purpose, 1, 2, 3, 4 is easy, right? Even though your index is 0. So index plus 1, I will make it 0, 1, 2, 3, 4, 5, 6. But actually this location is 7th, right? So that's why I can say your element is found at 7th location, but your index is 6. So I can say I plus 1, right? Item is found at location %d, comma, I can say I plus 1. Okay, that's up to your requirement. Okay, break. Okay, I'll come out of this. Okay, I will come out of this. So this is the logic you should understand. So after, even though this entire loop is completed, okay, but still you have not found your element. Okay, that means this item equal to f a condition false. Then after coming out of this, okay, here I can check another one. If I is greater than 9. See, since it is entirely block is only one condition, right? So this for loop open and closing brace is also not required. In the basics time we have given like that, right? Yeah. If I is greater than 9, greater than 8, you can say. Okay, greater than 8. What you can say, or greater than 7. Greater than 7. Okay, y value is greater than 7. You can say your element not found. Printf item is not found. So, my dear students, you should understand the concept here is, assume that you have 100 elements. Your element to be searched is located 99. How many times you have to search? So first, second, third, 4, 5, 6, 99th element. That means that many number of iterations we have used, right? So this is called every iteration. Okay, we can call it as iteration. Okay, for every iteration you are checking, yes, is this found or is this found? Is this found? No, then move. And is this found? No, use this found. Like this, you are searching each and every element, right? Say for example, if you have 10 elements, you are searching 10 times. If you have 100 elements, you are searching 100 times. That means n minus 1 number of times you are searching. Okay. So that means in this sequential searching, and also called as linear search, the number of iterations are more. Number of iterations are more. You are not skipping anything logic here. Okay. So in the next example, you can understand it won't take this many number of iterations. Do you clear about this number of iterations? Should I search sequential one after the other, whether my element is found or not? Are you clear about this? Yeah, Naveen Kumar is asking, explain once again. Yeah. See, this is linear search. Okay, that means simply the topic is you are going to search an element in the given array. Say for example, my input, what is your input? Any number you give, some 2, 5, 7, 8, 12, and 56, something number you are giving as an input. Okay. So you want to search. You have given any element you want to search. Say for example, you have given another input is item 8. So what is your output? The element is found. Okay. So what is this numbers? That may be either your ID or product ID or employee ID or student ID, your registration ID, whatever it may be, you assume. Okay. If you want to search in the hotel room, before reserving one hotel room booking, they will search whether this particular room is available or not. When you go to a reception counter, they will search with room number 101 is there or not. Okay, they will be having some kind of search key. See, generally where we are using this one. Okay, see, even while you are getting some kind of your marks memos, you are searching like this. Your registration ID in the forms. Okay, you are giving your registration ID. There will be a button called search. There will be a button called search. Have you observed or not? Okay. So whenever you give your ID, something 10, okay, 1177, something you give, when you press this button, you are getting all your details about the particular student, marks or something. One form is displaying. If this number is not found, you are getting the student registered is not there. Are you getting my point? Any hotel booking and product ID and employee details, student marks memo, whatever you want to display, you are using searching. Are you clear about this topic? So how can we do this? When you search this button, it is there or not. If it is there, you are displaying entire data. But as part of the simple C programming, I am going to display only that the item is found or not. I'm just displaying your student detail, your student ID is found or not. That's it. I won't display all the details of student relevant once it is found. I'm not doing any application here. Just a part of that, we are going for searching techniques. Okay. Do you understand about the topic first? My dear student, please chart. Yes, Surya, why I removed? Okay, I will tell you. If you want, you can put, say for example, you take for loop, any for loop, any while loop, for loop or do while loop or if conditions, anything, okay, I equals 0, something, I less than something, you take any for loop or something, okay, immediately you have some kind of statements, printf something welcome, okay, and you can say printf second line. Okay, I can say welcome to, I can say Blackbuck. Okay, now you tell me which statement will be printed. This I want 0 to less than 7 means 8, 7, less than 8 means 0 to 7 means 8 times. So 8 times statement will be printed. Which statement will be printed? This all the 3 statements will be printed 8 times. Somebody asked why you have removed brackets, my dear Surya. You try to understand here. Okay. So only by default, only this statement will be there. 7 times 0 to 7 means 8 times only first line will be executed. That means by default you no need to use braces for one statement. Are you clear? If you want a group of statements under the block, again all the basics we covered earlier. Okay, if you want to make it all the statements as a group, you can put the brackets. Otherwise, you want only one statement within the loop, what you can do, one statement you can put in the loop, then remaining you put in the outside of the loop, right? So what I'm trying to say, if it is one statement in the loop, you no need to mention the braces. By default, the loop will consider one statement. If you want, you can put, both are same, either with braces here or without braces, both are same. Why? Because under any loop, by default, one statement will be considered. Similarly, even though in case of if statement is one statement, right? Under the loop, I want to take only one statement. This is entire thing is one if. Okay. If you want, you can put it. No problem. Okay. After for loop only, I'm checking this statement. That's why I written outside of this. Okay. That is the purpose. Now, are you clear about the topic? Today's topic? Today's topic is searching techniques, right? If I give you this input like this, your element to be searched is item 8, your number is 8. What is your output? Tell me. What is your expected output? Element is found. And also at location 4. At location 4. 0, 1, 2, 3. But I want 1, 2, 3, 4th location. Now, if you give your input item is like 99, what is your output? Element is not found. This is the expected output. This is what I'm trying to explain. So this now for this we have two techniques. We are using two searching techniques, basic techniques. Okay, what are the two basic searching techniques? One is linear search and the second one is binary search. Are you clear? One is linear search and another one is binary search. Now, as the first part, I'm telling you, we are discussing about linear search techniques. In this linear search techniques, what are the logic we have explained now? That is the logic. Every item you should identify, you should search, and finally, that means it will take number of iterations to find whether the element is found or not. So it takes number of iterations. Let's see. Now, when we discuss about binary search, you can understand with less number of iterations how we are going to search the element. Okay, fine. Now let us run this program. Yeah, I'll create like this. Yeah, so what are the inputs we have? We should give two inputs. One is the number of elements and the element to be searched. What is this? Example program on linear search. Okay, fine. Now hash include stdio.h main. The same program you can do using functions also. Okay, you can use linear search as a function. So to cover both models, one is with functions and another one is without function, I will explain binary search using functions. Okay, you can substitute using the same functions, any program. Okay, I'm going to take my array with size of 10 and the index value purpose I variable and the item and the size purpose I'll take n. Now printf. Say for example, you want to take n number of elements, right? So I can say the array also I won't use the fixed. Enter number of elements of an array. Enter number of elements. Enter number of elements of the array. So that means how many number of elements you want to take? Nothing but size of the array. You can call it as size of the array. Okay, that means 10 is the maximum size. But while reading, you can take 5 elements, 3 elements, 4 elements. That's up to you. But maximum is the 10, right? I won't read all the 10 elements for every time. You read it into the variable n. So that means, I already told you in the arrays concept how to read n number of elements. So I can say enter elements. Okay. Otherwise, you can say enter how many number of elements. If your n value is 5, enter 5 elements, like that, right? So you can display that also. Comma n. That means what happened? If you enter the size is 5, enter 5 elements. Your size is 10, you can say 10 elements. Like that, it will be displayed. Okay. Enter that many number of elements. Now you should read all that elements. How can we read in the array? You should read using for loop, right? For I equal to 0, I less than n, I plus plus. Reading n number of elements. I hope you all practice the arrays. Scanf %d, comma, ampersand a of I. That means one step is completed. What is that? We just given the 5, that means 0 to 4, right? 4 elements. That means 5 elements will be given as an input. Okay. Now tell me what is the next step. Once input array is ready, now in the searching, what else input is required? Enter the item to be searched, right? So I can say printf. You need to read the item to be searched. Enter item to search. Okay, you should read those item also. You want to search nothing but you should give which item you want to search. So that I can store in the variable item. Any variable you can take item. Okay, that is fine. Now my actual logic will start here. Now my actual linear search logic will start here. Linear search. How you are going to search? Simply for every item. How can I write? My array is for I equal to 0. Okay, equal to 0. So maximum size is 10 I have given, right? I given maximum size is 10. So maximum size is 10, right? 0 to 9. So I can say less than or equal to 9 I plus plus. And then what is our logic? If item equal to, I'm comparing A of I. This is what our logic, okay? Yes, if this item is available, what you can say? Printf item is found at location. Which location it is found? I plus 1. Why I am saying I plus 1? I don't want index 0. Even though it is first location is available, I want at first location. Okay. Yeah, item is available at first location. Then immediately I will come out of this. I don't want to continue. Simply I'll come out of that loop. Then still end of this also, if you are not found, I can say my I value is greater than 9. I can say, okay, I can say element is not available. You can say item does not exist. Okay, fine. So like this, we can search in any easy manner. Simply just looping starting to ending. The item you are searching like is equal to A of 0. Yes, it is equal to A of 0. Item is found. Otherwise what happened? I closed this. Then I value becomes 1. Item is equal to A of 1. No. Then continue. 2. No. 2. Continue. If it is found, simply you got item found. Break. That's it. Okay. Otherwise, what will happen? You will get it. Item does not exist. After come out of this, still if your item is not found, it will check I value is greater than 0. Then you can say item greater than, no, item does not exist, right? So let me save this. I given linear underscore search dot c. Okay, linear search dot c. Let me run this program. Yes, program is executed successfully. Enter the number of elements of an array. Okay, let me give 5. That is my size. Enter 5 elements. Yes, what is the 5 elements? Number 2, 4, 7. Why I'm saying again 3? It is in zigzag manner. Okay, and then next one is 13. Yeah, these are the elements I given. So enter item to search. Give me 3. 3. What is the expected output? Item is found at location 4. See, 1, 2, 3, 4. Item is found at location 4. You should search on all the ways, right? Item is not found also, you should identify, right? Whether your program is identifying or not. So now enter the size of the array, right? Number of elements of an array. I'll give you 6. Then this program is allowing for up to maximum size of 10, but any value of the size of the array you can give. I can say 5, 23, 56, 78, and 2, and then 66, right? After that, enter items to search. Sorry, I ask 99, right? 99 is not there. So you got the output message. Item does not exist. 99 is not there. Are you clear? Yeah, like this. You can identify the linear search. Okay, searching the element. Fine. Now let us move with another type of searching technique that is more important. The technique is called binary search. Okay, let us move with this binary search. Yeah. So try to understand the binary search. This is, little bit complicated, but if you observe, it is very easy. If you identify, it is very easy. See, in this binary search, the prerequisite is elements should be in the sorted order. If you want to go for binary search, the prerequisite is elements should be in the Yes, that's correct, Surya. Okay, that's correct. So I kept for loop in only one condition. That's why I removed braces. That you practice, no issue. You can put and you can remove it. You should search in multiple ways. Okay, then only you can understand well. See, the programming, when you want to learn the better programming, okay, what you have to do, you should do multiple ways. Okay, yeah. Fine. So now, my dear students, all of you should listen carefully about this topic. This is binary search is very, very important, as well as try to understand the logic, not like simply like linear search. Okay. So try to understand, carefully. So now in this binary search, the element should be in the ascending order. Did you observe this or not? 3, 6, 7, 11, 32, 33, 53. All the elements are arranged in ascending order. Okay? You know the ascending order and descending order. Like the elements should be increased in manner. For now, which element you want to search? Okay, that is target equal to 7. Just given your element, which element you want to search? 7. Number 7 you want to search. Now see, in how many iterations we are going to complete. Even though you have given 53, in linear search it will take 1, 2, 3, 4, 5, 6, 7 iterations. But whereas here, very less number of iterations you are going to complete. Let's see how. Yeah. Now, my dear students, you should understand very clearly. Okay. So first I will explain like this in the PowerPoint with animations. Next I will explain with the notepad. After that, I will give the logic and then I will implement. These are the flow I'm going to explain. I'm repeating. I'm going to explain in the PPT. After that, I will write it manually in the paintbrush. After that, I'm going to explain the logic followed by execution. These are the flow. I'm going to explain the binary search. Now, you should understand what is this first arrow? Begin. This is the end and this is the midpoint. Okay. So assume, not this one actually. Assume that this is the starting and ending. Assume that an array is starting and ending. What is the index of the starting index? 0. What is the ending index? 6. Okay. So 0 plus 6 by 2. What is the mid? Index 3. Are you clear my point? 0 plus 6 by 2 is 3. So index 3 is the middle point. Even though you have, since here you have 7 elements, it is easy to find. Even though you have 8 elements, 8 means, okay, 0 plus 7, 0 plus 7 by 2, 3.5. It will take 3 only. So you will take third element is the array. Index third is the middle element. Okay, numeric part you are going to take. Okay, so you are going to find the midpoint. Are you clear? So 0 plus 6 starting array and ending index of the array by 2, you got the mid array. Fine. So this is very, very important here. Now your entire array is going to split into 2 parts. After the mid, before the mid is entire thing is one array. After the mid element, this entire thing is the another array. Are you clear now? So now this one array you are going to split into 2 arrays. How you are going to split? Based on the middle element. Without considering about without thinking about the elements in that, you just consider index only, right? What are the elements is there in this? What are the elements? Okay, the middle element is the third index. Fine. Now, before mid is the one index, one array. After the mid is the another array. Now, what I want to do? Yeah. Now, my first condition is your target variable is the middle element? I'm repeating. Is the target element is the middle element? My dear students, I'm checking 3 conditions. Your target, after finding the middle element, if your target element is the middle, then immediately in one shot you got the output. If not, it may be either less than your middle element or greater than the middle element. If your target is the greater than the middle element, you should take only the second part of this array. If it is the less than, you take only this part. You can omit this entire part. Are you clear? So 50% of the array you no need to search. After finding the middle element, 50% of the array you no need to search for the element. Okay. So now in this case, your target is 7. So is 7 equal to mid key? No. Condition false. Then immediately is your target element is there in the right side of this or left side of this? That you are going to identify. So is the 7 is less than the midpoint key? Your 7 is less than the midpoint. Yes, right? It is less than. Yes, condition is true. Is 7 is less than the midpoint key. So I will consider only this part. I don't want this again. So simply you no need to search right side of this array. You can omit. So in a single shot, I removed 50% of the array. No need to search. My dear students, that is keep in your mind. Yeah, then immediately what I can say, I just removed this entire part, right side and say including this. So now here afterwards, I consider only this part of the array. I consider only this part of the array. Again, your program started. Again, what is your starting concept? Again, you should find the middle and your searching element is the less than or greater than. This is only one step. Same step I am repeating now. Are you clear? Yeah. Again, you start with this. Yeah. What is your array now? Array, how you are going to identify the array? This is the array. You are removing this. Once if you feel that this is the end of the array. This is the end of the array index. Your starting index is 0. Your ending index is 2. Nothing but this is your total array. Now, tell me what is the mid? 0 plus 2 by 2. 1. So, can I say this first index is the 6 is the middle element, right? Yes. So, find the approximate midpoint. Now, your search element is 7, right? So, is this less than the 6 or greater than the 6? Greater than. So, I am going to consider, okay, is that key? Okay, target is equal to mid? No. Then next step is it less than this point, key point? No. Then I can say, is it greater than? Yes, it is greater than. Yes, it is the greater than. Then I can say only this part. I can say only this part, right? I remove this one and this one. So only till now, 2 iterations completed. One is I just removed this one and the second I removed this one. See, only it is left one element. This is the starting, this is the ending, this is the middle. My dear, this is the array right now. So this is the starting index, this is the ending index, this is the middle index, right? Yeah, is that, yeah, that is the midpoint, right? Is the target equal to midpoint? Yes, target equal to mid only, no? 7 equal to mid. Yes, then your element is found. Otherwise, you can say element is not found. Okay? So this is the logic. I hope you understand this logic. Can anyone ask, can I repeat this logic or shall I move ahead with the program? Yeah, program logic. Now you understand about the theoretically. How can I do the program? Yes, very good question, Anirudh. What will happen if an array has same element 2 times in different indexes? Very good question. Yeah, whenever I'm searching, okay, when I found that first person is already available, obviously my program will stop. That's it, element is found. Okay, element is found. Yeah, so now, yeah, now I'll go with program logic. Yeah. See, my dear students, you should understand the very important thing is in the binary search. Now I will tell you a small, program logic. I'll take the elements here, any elements, something like number 1. Otherwise, I'll take 12, 9. Sorry, can I take like this? No, right? So very primary requirement is, so can I do like this? Can I do like this? 41? No. Okay. So if you want to do if you want to do binary search, the element should be in the ascending order. Otherwise, you should apply the order. Okay. Fine. Now, after applying this any ascending order, now then your elements will be like this: 2, 3, 9, 12, 41. That means what? Prerequisite is this is not allowed since it is not in the any specific order, ascending order, right? Yeah. Now this is in particular order. Fine. Now I took only 5 elements. Otherwise, you can take 63, 6, 7, and 79. Take anything. Okay. Now, my dears, please tell me. Please tell me how you are going to identify whether an array is starting ending. That means this is the starting of the array. What is my address? Is 0, 1, 2, 3, 4, 5, 6, right? 4, 5, 6. Fine. Okay. Now, what is this variable? I can say it is the beginning. My variable is the beginning. This variable is the, what is this variable? Ending variable. End. I will take variables like this. End. My dear, tell me, what is the first? Beginning of 0. Okay. Beginning of the 0. Okay. And here end. End of the value is, okay, end 6. Array index is 6, right? Beginning 0, ending is 6. Now begin plus end by 2. Okay, begin plus end by 2. What is 3, right? So this third, 3 is the mid. So my variable is pointed to here, mid. This logic is more important. Earlier you got some idea. Now here the program logic you will understand. Without understanding this program logic, you will not develop the program, right? Now you tell me, you are going to search the element is 3. You want to search item is 3. What is the item? 3. You want to search item is 3. Your item is 3. Yeah. Now let us start. What is your mid? Here, right? Now how I am going to search? Is this item is equal to middle? Is this item is equal to middle? No, right? So that's why what I'm going to do. Yeah, this is not middle, right? I need to search whether my 3 is less than the 12 or greater than. In case of it is less than, then less than, right? So I'm going to off this entire the array. I don't want to search this entire the part. Okay, mid and also right side I don't want. Your item is 63, then your item is 63. Okay, my dear student, you may have another doubt, maybe 99. Even though it is not there, maybe 99. Yeah, still, if it is 99, I will remove this part. I will search here, even though it is not available. Assume your item is 1. Is it less than or not? If it is less than, I will remove the right side part. I will search, even though the element is not found. That you should try to understand. Okay, even though your element is not there, whether it is less or not, I will check. Even though it is 1, I'll see only this left side part. Even though element is not there, assume that it is 99. Okay, 99, but I will see only right side. I will remove the left side part. Likewise. Now, my dear, you tell me your beginning variable is pointed to starting only. Very, very important point I'm talking about now. Beginning is here only. Middle is removed now. Ending is removed. Now, what is my logic? Tell me how I can treat this is as an starting and ending array. Tell me, my dear. So now my ending pointer should point to here, right? My ending pointer should point to here. Then only I can say this is my array. Beginning is anyhow it is there here. Ending I should move to here. Okay, ending I should move to here. How can I move? That means the logic is ending is equal to middle minus 1. Ending is moved to mid minus 1. That is the end point. Mid minus. You try to understand this logic. This is very important. So end value move to mid minus 1. Then only I can treat this as an array. So beginning and ending. Say for example, if it is greater than, okay, up to this is okay. This is the middle only. Okay, assume that your searching element is 63. Your searching element is 63. So I should go for only greater than, right? So, okay. So which element I have to remove? From here to here I have to remove. Okay, here to here I will remove. Now you tell me ending pointer is ending only. What is the starting area of the element? What is the starting area of the element? That means beginning. What is the beginning value? Previously 0. Now what is the beginning value? Tell me here. What is the beginning value? Then only the array will be treated as a, okay, this is the total array I need to search. So beginning pointer is equal to mid plus 1. Okay, after the mid, right? So if it is greater than middle, then I can say beginning pointer equal to mid plus 1. Okay, mid plus 1. Otherwise, what will happen? Begin will be same. End will equal to mid minus 1. End equal to mid minus 1. I think, do you understand about this logic? Mid minus 1. If you clear about this logic, then only your program will understand. End pointer will move to mid minus 1. This first part. Okay, if it is greater than, if you take only this part, beginning pointer will move to after the mid. So finally, your array will be either mid before or mid after. Then only this array will be considered. So nothing but this is the array I am going to consider. Your beginning pointer is equal to mid plus 1, nothing but what? 4. Ending is 6. So this is the array, 4 and 6. Then immediately what is the mid? 4 plus 6 by 2, 5. So this is the middle again. You need to calculate like this. Are you clear about this? I need a quick response in the chat window. I need a quick response in the chat window for all. I need a quick response, all of you in the chat window. Yeah, Gangadhar, you're asking again one more time the logic. Yeah, I just said that your searching element is before the mid element. Then beginning pointer will be there. End pointer should move to the beginning minus 1, mid minus 1. So up to here, this is the array you are going to search. Otherwise, your searching element is above this 12. That means right side part. Then you want to consider this as an array. How you are going to consider this as an array? Your end pointer is ending only. Your begin pointer move to the mid plus 1. That means this is the next element. This is the beginning pointer. How you can say make this as a beginning? How you can make as this is a beginning? Mid plus 1. This is the beginning. So you can consider this array. Okay. So sometimes whether you are going to identify your searching element is less than the mid or greater than the mid. If it is less than the mid, this part you are going to search. Otherwise, this part you are going to search like this. Okay. So that is the concept. Fine. If you understand this, over. Okay. You can develop the logic. Okay. Beginning, ending, middle element. Now, let me run this program. Okay. Let me run this program. Once you understand, right, this is the beginning and the end, then if this element is 63, then what happened? Yes. So middle is the 65, 6 plus 4, 5. Okay, is your searching element is the 63. Obviously, first element itself, it is the 63. So in the second iteration itself, we got it. You find this. So you don't need to search entire the left elements. So this is the searching techniques. You can get, you are finding the element quickly. without wasting number of iterations. Okay, so let me run this program. Let us take this program. I'll create the new file. Yeah, same input is same, right? You need to give the size of the array, elements, and you need to enter the elements. Till that it is same. My dear students, first you should write the any program. What is the input? What is the output? Okay, your input is array and element to be searched and size of the array. Okay, so example program on binary search hash include stdio.h. So this time I will explain the same program using functions concept. You can do anything, right? Simply I can use functions. So always I'm giving void int main, right? Like that, right? I can also give void. That means my function does not return anything. Simply, you know that a function with return, a function with non-return, a function with argument and return, like this, all the functions are already covered. Okay, so I'm taking a function without return. And what are the variables I want? See here, I'm taking above the main. Okay, here, if I put void, I don't want to return statement here. I don't want to return of 0. If you put int, you can say return of 0. Okay, if I say outside of the main, why I'm saying outside of the main? After this main, if I write binary search, okay, void binary search. If I write a function, this is outside of the main, right? If you want to access your array, all the variables, that's why I kept here as a global variable. You know the global, if you declare outside of the main, those variables throughout of the program, you can access, right? I'll give the maximum size of the array 50. And what are the variables I'm going to use in items? And you tell me so far we have used, what is that? Beginning and ending. Okay, beginning, ending, and middle. Okay, we have used all the variables, right? Yeah, you want to display any location, you can display. Later, whenever it is required, we will display. And these are the things at this moment I remembered, and the remaining we can you will declare whenever it is required. Now enter size of the same like as a linear search. You should read the array size, right? Size of an array. First you take the any size of the array. So after that you read the elements of the array with respect to that particular size. Simply I'm going to read into the variable n. Now you need to read n number of elements, right? Printf. I'm giving something, enter one clue, enter elements in sorted order, right? That is mandatory, right? You should use sorted order. Okay. So how can I read n values? I equal to 0, I less than n, I plus plus, as you know. Okay. So, and then single, that's what I'm saying. So I want only single statement scanf, right? So you no need to mention here. So what happened on the main? This was added. What about this? This is extra. Yeah. Simply I will read scanf %d ampersand a of I. So n number of elements we are reading up to this completed, right? Now what is the next step? Tell me which element we have to read. Enter the item to be searched, right? Yeah. So you should give printf enter the element to be searched. Which element you want to search? I will store as usual into the variable called item. %d, comma, item. Yeah. Next. That's it, right? After that, immediately I will call binary search. Assume that my entire program I'll put into the binary search. I'm just calling that. There itself, if you want to return this value and you can print output here. Otherwise, I will just, my control will move here. Here itself I will do and I will print everything will take care here itself, right? Simply, I just cut this entire program here. I put in the binary search so that it is easy to understand this logic of the binary search. Okay. So now tell me in this, what is that beginning index is 0, right? Beginning index is the 0. Ending index is the, if it is 7 elements, 0, 1, 2, 3, 4, 5, 6, 7 elements, nothing but n minus 1, right? So end of the index is, ending variable index is n minus 1. Beginning index is the 0, right? So that's why I will give here my beginning variable equal to 0 and end element equal to n minus 1. Okay. So mid equal to, how do you calculate mid? Begin plus end by 2, right? I can calculate begin plus end by 2. Okay. Now you have begin, end and mid. Now you write the program. So the logic you can understand till the end of the loop. So the while begin is less than or equal to end, that I'll tell you, that is in the last iteration, you can understand very well. And that should be another one is a of mid item, a of mid, your element, middle element is not equal to item. That means if the element is not the middle element, then only I can say, right? See, if it is not your middle element, if it is not your middle element, are you understanding? If it is not middle element, then only I can check whether I should move to the left side or right side. Is that first point is clear? First I will check, is my searching element is the middle or not? If not, then only I can move to either left side or right side based on the checking, if condition checking, right? If the A of mid is less than or equal to item, then I can go left side, otherwise I can go right side, right? Yeah, that is what you have to check. If it is not equal to item, then only within that loop I can check. Okay, within that while loop I can check whether my item is less than the of mid or not, right? So what is that? If my item is less than a of mid, assume that if your item is less than the a of mid, you are going to left side part. You are moving to the left side part, right? If you are moving to the left side part, nothing but how you can identify ending is equal to mid minus 1, right? This is the end. End equal to mid minus 1. This is the left side part, right? That is how you need to write here. Your end equal to mid minus 1. Nothing but automatically beginning is pointed to same. Else your beginning equal to, if it is else, what I can do? If it is else, what I can do? Your end is same, but your beginning value should move to after the mid plus 1. That means what? Beginning equal to mid plus 1. I'll move this side, right? That is what I'm writing here. Here, beginning equal to mid plus 1. That is the logic is required. Okay. So finally, after calculating your beginning or end, whatever it may be, what is your next step? Again, should I calculate the midpoint or not? After making your beginning pointer or ending pointer move here, whatever it may be, you need to calculate again. Now your variables are ready, beginning and ending. Now you need to calculate mid. How you can calculate same beginning plus end by 2? Okay. Since I am in the loop now. That's why again I'm writing. I'm in the loop. That's why again I want to calculate the middle point. Okay. So this is outside of the middle while. So that's why first time I calculated mid here within the loop. That means again if you have very big array within the loop, you need to calculate again left side, right side, again right side, middle, like this. So I'm going to do middle equal to beginning plus end by 2. So finally within the loop I calculated ending pointer, beginning and middle pointer. That's it. Again, my loop is calculated. Is this equal to a middle? Still no. Then I can move my pointers. Otherwise, if it is equal to item, then I don't want. Condition becomes false. Any one condition becomes false, right? Then immediately I'll come out of the loop. Simply, I can check if my A of middle is equal to item, right? Obviously, if I come out nothing but what? It is equal to middle only, okay? Then I can say is that my item is equal to A of mid. Then I can say element is found. Printf, I can say item is found. You want location also? You can print location found at the location is which location? Mid pointer, right? Wherever your mid pointer is, that is the location. So it is started with 0. That's why I'll make it mid plus 1 for printing. I'll say mid plus 1. So simply that's it. Otherwise, I can say, okay, else element is not found. If the item is not found, no need of index, right? It is not found, that's it. Element is not found. That's it. Okay, I hope you understand this. Why I used end equal to mid minus 1, beginning mid plus 1. Okay, like this. Fine. Now I will run this program. I'll save this. I'll save as a binary underscore search.c. Let me run this program. Enter the size of the array, right? That is the first point. Assume that my size is 6. Give me enter the elements in sorted order, right? Give me 12, 16, 19, 21, 34, 56. 6 elements are over, right? Then automatically it is asking enter the element to be searched. I'm giving the right side part. You can find 34. Then item is found at location 5. See, 1, 2, 3, 4, 5. Otherwise, you want to 0, 1, 2, 3, 4. Then you should give only mid pointer, right? I given mid place 1. That's why what item location is at 5. Okay, shall we check with the element which is not there? Yeah, we'll check the element is not there. Enter the size of the array 6 and enter the elements 12, 34, 45, 56 and 67 and 78. Enter the element to be searched. I'll give you 99. Then item is not found. That means your logic is correct. Okay, always you should search with both ways. If it is found, where it is found. If it is not found, you should get it output like this. So these are the test cases. Element should be found and not found. All the test cases you should check it. I hope you understand clearly about this binary search. Okay, this is the way we can do the binary search technique. Yes, my dear Lahari, if it is 2.5, it will take 2. It will take 2 only. Do you understand? That is also I told. Lahari, if it is 2.5, it will take 2. Since it is integer, right? We are using integer part. So index is 2. That is also while explaining I said. In case of indexing, okay, in case of we have 7th element also. One more element. That means even numbers. The 0 plus 7, 8, right? Okay. So 0 plus 7 by 2, 3.5. That means 3. At that time also, it will take 3 only. Because 0 plus 7 by 2, 3.5 also, it will take 3 only. Are you clear about Lahari? Yeah. Okay. Yeah. So this is very good logic, and even though you have n number of elements, like you have 100 elements, 50% itself you will remove. Remaining 50%, again you are removing 50. Are you clear? First 100, first 50 you are removing. Within the next 50, again 25 you are removing. Right? Like this. Okay, what happening? See, here we have 1, 2, 3, 4, 5, 6. You take 100 elements. 600 elements. Okay. So after finding the middle point, conclusion I'm saying, if it is less than the mid, then I can remove this 50% of the elements, right? 50% I'm removing. Only 1 to 49 location I'm considering. After this, I'm finding 25th location is the again half. Again after that, I'll remove all 25 locations, only 25 locations. After 25, middle is the 12 locations. Again 12 I'll remove, only 12 I'll check. Again after 12, again 6. Like this, we are removing 50%, right? So that even though you have 100 elements with less number of iterations, we are going to found these elements. Okay, fine. Now, let us move with another topic called sorting techniques. Okay, what are the sorting algorithms we have? What are the sorting algorithms we have? A sorting algorithm is an algorithm that puts elements of an array in a certain order, either ascending or descending. When sorting numerical data is called the numerical ordering. If you are sorting, it is called alphabetical order. Okay, whatever it may be. Yeah. See, what is sorting algorithm? Sorting, nothing but what? Arranging the elements in a specific order. Arranging elements in a specific order. See, my dear, here only it is going to be very interesting sorting techniques. Arranging the elements in the sorting techniques, right? See, previously we have 12, 4, -2, 1, 20, 0, 8, 3. Yeah. Arranging these elements in the particular sorting order. What is your output? First -2, next 0, 1, 3, 4, like this, right? Is this output? So this is the arranging the elements in the sorting order. So like this, arranging the final output is arranging the elements in sorted order, like a specific order, either ascending or descending, fine. But while arranging these elements in the particular order, we are following various methods, various techniques. Okay. So those techniques we are going to discuss now. Okay. So all the various kinds of techniques like bubble sort, merge sort, quick sort, selection sort, index sort, bucket sort, radix sort. We have many different types of sorting algorithms are there. I'm repeating. If you want to sort the elements in specific order, if you want to arrange the elements in a specific order, we have various kinds of techniques, algorithms. That is bubble sort, insertion sort, linear sort. Okay, and not linear, and insertion sort. Okay, selection sort, quick sort, merge sort, bucket sort, radix sort. Okay, many various kinds of sorting techniques are available. So now, out of all the sorting techniques, again we divide into two methods. One is comparison based sorting algorithms, and other one is non-comparison based algorithms. Okay. So what are all the What are all the algorithms are comes under the comparison based? What are the algorithms comes under the non-comparison? Bubble sort, merge sort, pick sort, insertion sort, selection sort, all comes under the comparison based. Whereas non-comparison based, we have bucket sort, radix sort. We'll see all the sorting techniques one by one. Let us see bubble sort algorithm, right? How the bubble sort algorithm is going to be work. Try to understand very clearly. My dear students, try to understand clearly, then try to understand this technique clearly, and then we will run the program. Okay. So now all the elements are in something zigzag manner, either not in ascending and descending order, right? We need to arrange it in either ascending order or descending. Now we are going to do ascending order. Now, how I'm going to compare? See, the color combinations you should understand here. It is showing yellow color, the first sequence of two numbers, and then, okay, I change the colors here. That means those two numbers I have identified, and then I swapped. I'm repeating. I just identified first two numbers, that is for selection. Then what is my operation? Just swapped. You know the swapping. Once if you know A and B, okay, and how you can swap? How you can swap? You take temporary variable and you move this 4 to temporary memory location. Okay, move this value into the temporary memory location and keep this 12 into the second element and the temporary to the first location, right? Likewise, you can do this. This B value put into the temporary and A move to the B and temporary move to the A. That is the swapping technique we are following. Same thing I will follow. Finally, I got like this 4 and 12. Are you clear? Now these two elements are swapped. After that, I have selected continuous elements. Next, my first array, first element is completed. After that, I took the second two elements. And then those two are selected. I will swap. How I will swap? Whenever it is less than is, okay, first after that only, the next element will be there, right? If it is greater, then I will swap. So first element should be, that means minimum element will be first and maximum element will be right side, right? Like this, I will swap. Did I swap or not? So -2 becomes first, 12 is next. I am comparing only these two, okay, which is largest element, okay? So that element I swap. Now next, coming to 12 and 1 I have collected. Yes, that's good, Lahari. That's good. Same. A equal B and B equal temporary. Yeah, next term. Yeah, that will, okay. Bubble means sequence values we are comparing here. Okay, we'll see. Now, 12 and 1. Okay, so can I swap or not? You tell me. Okay, shall I swap or not? Since 12 is greater than the 1, then can I swap or not? Yes, if the 12 is greater than 1, I can swap. Okay, now next, is the 12 is greater than 3, can I swap or not? Yes, 3 and 12. Again, here 12 is, and comparing these two, can I swap or not? Yes, I'll swap. The next 12 is not 12, that is coming like that only, right? Any two consecutive values I'm checking here, okay? Every consecutive numbers I'm comparing, okay? Fine. Now, yeah, so I swapped 8 and 12. Now you tell me, I took 12 and 56. Shall I swap or not? Now we have 12 and 56. Shall we swap or not? Not required, right? 12 is less than the next number. So I don't want to swap. I'll take 56 and 31. Now, shall I swap or not? Yes, we can swap 31 and 56. 31 and 56. Shall I swap with, now I'll take 56 and 11. And shall I swap or not? Yes, we can swap. Now, my dear, after comparing each and everything, like two consecutive numbers, finally, I can say my last element is the highest number. Okay? My last element is the final, is the greatest element. That means out of all, my last element will be there in the ending position. So one iteration completed. What we call, how many iterations completed? One iteration completed. That is nothing but, okay. So one element is over. I can keep away. Next, I should take the rest of the elements. Next, I should consider the rest of the elements. That's why once it is over, my color is green. Okay. Now I will start my program. So until 11 only I will come next time, my dears. You should keep in your mind. I don't want to touch the last element. This is over. Now I will take the rest of the elements. Now the same process you start. Shall I swap these two elements? Yes. Yeah. Shall I swap? Take 4 and 1. Shall I swap? Yes. Take 4 and 3. Shall I swap? Yes, 3 and 4. By doing like this, you can understand the right side element is the biggest element, right? 4 and 5 should be biggest. That's why I won't touch. 5 and 8, shall I swap? No, right side is the greater element. So shall I swap 8 and 12? No, 8 is the less than. I won't touch. Shall I swap 12 and 31? No need. So right side is the greatest. Shall I consider 31 and 11? Yes, I should swap. Now 11 and 31 is swap. Now, my dear, shall I consider 31 and 56? No, why? Because I kept it. I don't want to go again one more time once my elements are over. Now 31 is the final. Now 31 is the final. Okay. So likewise. Now, what are the next time when we do the again sorting and again comparing these two elements, which element I have to consider? So first n-1, next n-2. Okay, these are the rest of the elements only I need to consider. This is nothing but what? 0 to n-1. Next time n-2. Okay, before n-2, next n-3 before. Like that only I should consider. This is the my next array. Okay. Now, shall I take these two? Yes. Shall I swap? No need. Shall I take these two? Yes, I can. Okay. So shall I swap? No need. Can I take these two? Yes. So 3 and 4. Shall I swap? Not required. Now 4 and 5. Shall I swap? Not required. Shall I swap 5 and 8? No need. Next consecutive elements are 8 and 12. Shall I swap? Not required. Shall I swap 12 and 11? Yes, we should swap. So now it becomes 12. Now, is this over? 12 is the. So do you understand? Out of this array, last element is the highest element. Okay, like this I did it. So iteration 3 is completed. Iteration 3 is completed. Now, before 12, I'll take only these elements. So again, consecutive elements. Like this, we should write the program. These two, yes, no need to swap. These two, no need to swap. These two, no need to swap. 5 and 8, no need to swap. 8 and 12, no need to swap. Now the last element is the highest. Can I make it as a finalized element of the 11? Yes, 11 is the finalized. Now I will take minus 12 and minus 2 and 1. 1 and 3. 3 and 4. 4 and 5, no need to swap. 5 and 8, no need to swap. Can I consider 8 is the maximum? So it is the finalized. Okay. Now, even though you understand all are in arranged, but the program should stop. You should not stop. That you should keep in your mind, my dear students. Okay. Program should stop you. You don't stop. Even though you feel that your program is completed, but program is not recognized. Program should say that your program is completed. Okay, fine. Now you should take next minus 1 and 1, and 1 and 3, 3 and 4, 4 and 5. 5 is the maximum. So that's why that is completed. So how many iterations? 6 iterations completed. Now these two, right? So 4 is completed. Now these two, minus 2 and 1 and 1 and 3, 3 is the completed. And these two compared and this is completed. Finally, the minus 2 is also completed, right? So now this is the way we should compare two consecutive numbers like this, all consecutive numbers. Finally, that element will be completed in the arranged order. And before that, you should consider, after completing the array, the before array, you should consider starting and ending. That rest of the elements you have to consider as the array, and you should do the same process till all the elements are in arranging order. Yes. Now, my dear students, this is the way we can do this bubble sort. Maybe selection sort, insertion sort, bucket sort, merge sort, quick sort. It depends on the algorithm. The way of arranging the elements, the logic will be different. And finally, you need to understand which algorithm is the best algorithm based on your time complexity. That I will tell you end of the topic. Otherwise, if I say starting itself, all the time complexities and all, you will get bored. Okay, that's why I will tell you once after completing the algorithm, I can tell you what is the time complexity of the every algorithm. Okay, fine. So this bubble sort algorithm, the logic we will implement in the next session, and I'll try to implement that. And the rest of the sorting algorithms also very interesting. And till then, in the next session, we are going to execute the rest of the algorithms. Till then, happy learning. Have a nice day.
Thank you, sir.
Yeah, thank you. Thank you very much. So in the next session, we'll run this program.